with section 7, working with lots of equations in this. We'll see linear equations come back again from algebra 1 and algebra 2 with one variable, with fractions, rational equations, with variables in the denominator. So this will be dealing with fractions also. Don't get intimidated. We can get through that. We'll solve a formula for a variable with a just general equation. This might look similar to what you've seen in physics. Solving equations using absolute value, which we won't see too much collectively in pre-calc, but it's nice to see it again, knowing that this is going to have two answers. Most likely. Sometimes there's just one. Sometimes just zero, but two answers for the most part. Solving quadratic equations by factoring, using square root property. This is algebra 2 towards the end. Completing the square, which is a newer type of way to factor. You might have seen that in algebra 2. If you haven't, I'll catch you up on that. Quadratic formulas making an appearance with this long equation. Negative b plus or minus the square root of b squared minus 4ac. And that's all over 2a. This is kind of a worst case scenario equation you can use if you get stuck trying to factor and solve an equation. We won't see too much of the discriminant. We will see efficient methods of when to factor and solve quadratic equations, and also getting rid of radicals that are in an equation by most likely squaring or cubing or taking whatever radicals root is to that power. So with this first problem here, we're being asked to solve, and we have a rational expression of -1 divided by x plus 1, and this equals 1 over 3x plus 3, subtracting 2 divided by x minus 4. This has a lot going on with it. Previously, with rational expressions, we've seen that we need to have the same denominator before we can really start to focus on combining the top. So that's an important goal. So our goal here is trying to get common denominators. As we see from these three fractions, there's not much going on that looks similar. You might notice that here this is 3x plus 3. Is there a different way that we could rewrite this? Is there anything we can factor out? So we could treat this as 1 dividing by 3 and x plus 1. So we can factor out that 3. Because one of the fractions has x plus 1 in it, and if we can get these to match up already with x plus 1, that makes our life a little bit easier to work with. So the goal here eventually is going to have a denominator with these three expressions, x plus 1, 3, and x minus 4. So let's make a note on that. In our denominator, we want 3, x plus 1, and x minus 4. And this is going to be using cross multiplying to try and get the same common denominator. So if we look at this first fraction here, trying to change this denominator, what should we multiply the top and the bottom of this fraction by to eventually get these three factors, 3x plus 1 and x minus 4? What would we have to multiply this by? Pretty much what's missing. So hopefully you're thinking that 3 is definitely missing. So we'll multiply that with a factor of 3 in the top and the bottom. This is also missing x minus 4. Making sure to distribute that to the top and the bottom. For the middle fraction, this is missing x minus 4. So we'll multiply that to the top and the bottom. This can be a little tricky to show. So I'll write it down here. Still trying to get common denominators, so multiplying this with x minus 4, x minus 4. And then for the last fraction, what do you think we have to multiply this top and bottom by to end up with a common denominator with these three terms? You should be saying 3 for the top and the bottom. And also x plus 1, that's missing in both of these, the numerator and the denominator. So let's double check. We know that when this is all multiplying, we'll have the same common denominator with 3x minus 4 and x plus 1. We'll also have that with the middle fraction here. We'll also have it with the final fraction here. So now that we have aimed towards getting common denominators, that part's done. Now we're trying to combine and simplify the numerator. And I think that this is a good strategy right here, making a note on what your ideal common denominator looks like if you're solving an equation where it's a rational expression. I think this helps keep your thoughts together. You don't lose track of the goal at hand, trying to cross multiply to eventually get here. Switch papers on this. So we're trying to end up with the same denominators, we got that, and now we're trying to simplify the numerator. So for the top, we multiplied this -1 with 3 and x minus 4. So we have -1 multiplying with 3 and x minus 4. This should be equal to 1 multiplying with x minus 4. So x minus 4 for that second fraction. I'm just focusing again on numerators here, so if you're stuck on which fraction I'm working with, this was the first, -1 times 3 times x minus 4. Second fraction, 1 times x minus 4, and then we're subtracting the product of 2, 3, and x plus 1. So for this, if we go from here, simplifying where we can, we'll have -3 multiplying with x minus 4. This equals x minus 4. We're deducting the product of 2, 3, and then the sum of x and 1. So we're deducting 2 with x plus 1. Solving from here, distributing 3, -3x, and then adding on 12. Subtracting 6x when we distribute, keeping in mind we're also distributing to +1, so make sure you deduct 6 here. If we combine like terms where we can on the right-hand side, x minus 6x gets us -5x. -4 deducting 6 gets us to -10. This still equals -3x plus 12. So just a little bit of algebra left over here. If we combine terms to one side, I'm going to go about this by adding 5x. So I work with positive exponents, or sorry, positive coefficients. Getting rid of 12. -3x adding 5x gets us 2x. This is all equal to, with this canceling, -10 minus 12, so -22. If we solve for x, this should be equal to -11. If you decide that you want to check your work, this is pretty extraneous and pretty extra to check your work on this, but it's totally possible. So we're saying x is -11. Plug that back in, it should get all of this. Deducting 2 over -11 minus 4. This ends up as -1 over 10. This ends up as -1 over 30. And then deducting, well, no, you'd be adding because this is there, adding 2 over 15. Which should end up where we need to be. So you can say that our answer is -11. If you want to check this, go for it, but I'm pretty confident with this.